Okay, first I thought I would show you a ring magnet. Now, I can see I have 7 RGB LEDs here. 1, 2, 3, 4, 5, 6, 7. Now, the more LEDs that I add, I mean, there's only so many LEDs that I can add, but the more I add, the more complete the pattern is of the hypertrochoid. And people say, well, what's a hypertrochoid pattern? Well, it's a spirograph pattern. Then people realize what you're talking about. So let's take a look at this before we get on to the main demonstration. Then after that, I'm going to switch over to white light LEDs, and you're going to see something completely, well, you're going to see the same thing, except a much more detailed image. So you can see that instead of a complete hypertrochoidal pattern, we're seeing a partial one, but that's only due to the number of RGB LEDs that are painting this. Now, right now, I have white set on my RGB LEDs. Let me put it on blue, green, red. Now, the higher the frequency towards the blue, you'll notice there'll be less light, especially at the dielectric inertial plane, but I'm going to show you that in a second. Let me throw it on white. White is just RGB lit on all of them. But I want you to notice something before I switch over to the regular magnet instead of the ring light. Now you notice this blue lobe on the interior of the ring light. Now as I move it towards the light, we'll get a blue shift, and further away we'll get a red shift. I can't demonstrate that very well using the ring magnet, but let's do it in a very obvious fashion so that you can see exactly what I'm talking about. And let's use, you look for the pole on this one. Let's first throw it on the pole. Bring it down here so you can see it. This is either pole of a 1-inch N55 Gauss neodymium iron boron. Like I said, you can see each point here. You can see the red, the green, and the blue. I'm filming this on a Zeiss 50mm, by the way. f1.4 Zeiss, Carl Zeiss. Let me see if I can come into focus a little better. There we go. You're going to see a lot more complete hypertrochoidal pattern once I switch to the white lights in the next video. Let me center this up. Now let's throw things along the dielectric inertial plane and show you something that nobody on Earth has ever seen before. Okay, now we're going to see the phase shift. Okay, well that's the phase shift. By the way, this was my discovery. You'll notice if you look closely, if I turn the magnet right, you can see it a little bit better. But along the dielectric inertial plane, here's either pole. I wish you could actually see this in person, because you literally do have over 3 inches of depth on a ferrofluidic solution that is less than 1 micron thin. Oh my God. Here along the dielectric inertial plane, either these little black hole looking formations over here, that's either pole respectively. Now, my discovery, uncovering missing secrets of magnetism, not only did I make this discovery last year, but I also discovered the mathematical formula for the phase shift existing at a ratio that is unrelated to the Gaussian flux, which is equal on either pole of a magnet, that this phase shift of electromagnetic retardation from phase shift polarity on a coherent dielectric field, as Faraday called it, i.e. magnetism, exists at a ratio of 1 to 5. This accounts for EM retardation, which is a known entity. Now, relativity has incorrectly explained this to be due to space warpage, but we know this is purely an electrical phenomena. Recent discoveries in they call it gravitomagnetic phenomena discovered from a spatial probe prove that this be the case. We can use simple Steinmetz and Maxwellian equations for magnetism in place of relativity's equation as far as warp space, because Tesla said this was an absolute absurdity, and of course it is. But here you can see the RGB LED along the dielectric inertial plane, the red, the green, and the blue. But you'll notice, if I clear the ferrocell out here, I actually didn't have to do that. You'll notice a green shift over here and a red shift over here. Now, I don't know which pole of the magnet I have underneath the ferrocell right now, but I do because of color. Now, green is a higher frequency, it's toward the blue end of the spectrum, and red, of course, is a lower potency electromagnetic radiation. Light is a coaxial circuit. Z-axis dielectric with transverse electrical and magnetic. Remember, electricity is phi times psi equals Q in Planck electrification. Electricity is a hybrid of dielectricity and magnetism. This is an irrefutable fact. I mean, this has been known for a very long time. But what you're seeing here is not a Gaussian reading. We're not taking Gaussian flux densities, which would be equal along either pole. What we're seeing is a phase disparity shift on either pole. And hold on a second, I'm going to show you the important part. Okay, because I've shown this video last year, and this was my discovery. Even the inventor of the ferrule cell didn't know about this, and he confirmed it himself after I told him about it. Here you can see the RGB right along the dielectric inertial plane, the midpoint of the magnet, as the point of the self-centering incommensurate point between either pole. The magnet does not have poles, it has the inverse of counter space. Magnetism is the dielectric field, quote-unquote, from Faraday. But here you can see the green shift, here you can see the red shift. This will be tilted blue, but it's shifted towards the blue. And it exists at a ratio of 5 to 1, or 1 to 5, depending on which side of the pole you're looking at. Obviously, now over here we're looking at compression. And over here we're looking at rarefaction. That's why it's redshifted. So a magnet that is perfectly still. See, nothing in the universe is perfectly still. This is why Newton's third law is incorrect. Nothing is perfectly still. But the phase shift disparity of any magnet, whether it's a powerful neodymium or ceramic or samarium cobalt, doesn't matter what it is, always exists. And this is at the atomic scale as well, because the only thing that defines a magnet is a coherent polarized field throughout the entire atomic that exists on the macro scale, and therefore we have the magnet. We have a coherent magnetic and dielectric field. Magnet has been made coherent. The same difference between 5 watts of incoherent light radiation from a light bulb versus 5 watts of a laser. One is worthless to read by, and the other one will burn a hole in your ass. Okay, we're talking about a coherent field here. Now what we're seeing is the phase shift. Okay, doesn't matter how I turn the magnet, we're actually seeing the phase shift. Okay. Now let's show you something else. We know blue shift, and you know what red shift is, or at least I hope you do. Something's moving away from you, red shifted. Light source is moving towards you, it's blue shifted. Now let's take a look at something, okay? Getting blue shift. Over here we're getting red shift. We move over here, we're getting blue shift. Over here we're getting red shift. Doesn't matter how I turn the magnet, doesn't matter if I use white light LEDs or RGB LEDs, or if I turn on, it'd be harder to see, however. Doesn't matter if I turn on the red, the green, or the blue. You can't see it in the blue because it's all blue light. But if you were able to discriminate with tighter eyes, you'll actually see, of course, this blue is brighter because I've moved towards this. I've got blue shift over here, and over here I have red shift. That's why the blue is weaker here. Now, I really wished you could see this in person, because you're looking at less than 1 micron thin of ferrofluid, but you're actually seeing nearly 3 inches of depth. And you can't see that through what I'm videotaping right now through this Carl Zeiss lens in my Nikon D750, but it is there. Many people that have handheld the ferrule cell can obviously see that, and they're going, oh my God, where's this depth coming from? It's far, 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 far deeper than even the best art hologram. The hologram on your credit card is crap compared to an art hologram. And the ferrule cell makes even the world's best art holograms look like crap by comparison. Most people have actually never seen this device before. You can get this ferrule cell. No, I get no kickbacks. I get no money from it off of ferrulcell.us. You can purchase the ferrule cell if you want. No, I'm not selling anything. It's not my invention. It's Tim's invention. But let me put it back on white light. Blue, green, red. You notice why the red's so much brighter? And the blue is so much dimmer? Well, I've talked about in that prior video. So let me throw it on red here again, let the camera adjust. But whichever way I'm actually dragging the magnet, I have blue shift towards approaching and red shift towards trailing. Blue shift, red shift. Doesn't matter how I turn it. Blue shift, red shift. Blue shift, red shift. Blue shift, red shift. Doesn't matter. I flip the magnet around to another side of the dielectric inertial plane. Doesn't make any difference. Blue shift, red shift. But at the center of the ferrule cell, we know that this is the north pole and that's the south pole because this is red shifted and that is blue shifted. It's greenish blue, but that's the blue shift. That's the south pole, this is the north pole of the magnet. This is exactly why I made a 6-video series a few months ago showing you that and these experiments were replicated by Rawls and Davis many years ago, why seeds, North Pole exposure, South Pole exposure, come out completely different. The North Pole seeds come out tasting bad. I've done this experiment over and over and over and over and over. It's always the same. It affects worms, chickens, any and all seeds. It affects animal growth. They've tested rats, chickens as they're hatching. It tested anything that grows. And it will always have a phase shift. Always. This is seed exposure only, but you can do seed exposures as they're germinating too. Same effect, except slightly more dramatic. Blue shift, red shift. Blue shift, red shift. Nobody has ever seen this before in relationship to the feral cell. Nobody. This is the first video on Earth like it. You're the first person to see it. Absolutely guarantee you that fact. This discovery is mine. Copyright 2014. Uncovering the Missing Secrets of Magnetism, as found in the 3rd edition. I'm well into the 4th edition. There'll probably be 6 or 7 editions. I have a tremendous amount to add to the book. But blue shift, red shift. Blue shift, red shift. Blue shift, red shift. You see what I'm referring to? And along the dielectric inertial plane, you see the red, green, and blue. You see all patterns of light. They'll all terminate right in the center. They start dipping in. This is where the notion by Lead Skalin, who was wrong, he wrote a book on magnetism, is very childish and is very juvenile, but I mean, he didn't know. This is why some of these people said a magnet has 4 poles. They're actually referring to the dielectric inertial plane as being segmented out in 4 quadrants, either pole on the dielectric inertial plane. Actually, a magnet has no poles. It just has the inverse of counter space. The inverse of counter space, i.e. non-Euclidean geometry, well, it's what the idiots of quantum call zero-point energy, or what those idiots also call dark matter, is nothing other than unmanifest inertia. The loss of inertia can only be expressed in one fashion, and that's magnetism. That is what magnetism is. It is the reciprocating processional. You know what precession is? Reciprocating, you know what that is? Not difficult, sounds difficult. Reciprocating processional hyperboloid, which can only extrapolate itself out in a hypertrochoidal fashion. Now, you're the first person in the world to see this phase shift. Red shift, blue shift, red shift, blue shift. Doesn't matter how I turn it. These are all evenly spaced. Doesn't matter if I use white light LEDs. Doesn't matter if I crank it to... of course, I can't see in complete and total darkness here. Doesn't matter if I shift it to the red, the green, or the blue. Blue shift, red shift. It's still all green, but it is blue. It is red shifted over here. It is blue shifted over here. That's why it's so much brighter over here. Doesn't matter how I turn it. You see, I have shift right here. This is the phase disparity. It exists at a ratio of 1 to 5. My discovery. This is Tim van der Relly's invention. But I didn't find his invention or discover his invention until I was well into the 2nd edition of my book, Uncovering the Missing Secrets of Magnetism. My formula is proven out by many test media. There is a vortex that exists along either pole, quote unquote. We speak conventionally here as referring to a pole. Here's one of the poles of the magnet. There is a vortex that exists there. I have my own invention. It's a special ferrofluidic suspension, and I've got a video on it if you want to traipse back that shows the vortex. If you actually place a magnet underneath my special ferrofluid suspension, it will actually form a tornado-like vortex and spiral in towards the pole of the magnet. So, you're the first people to see this, and try finding any scientist to refute this, because they've never even seen this before, and they've got nothing to refute. And there is nothing to refute about electromagnetic retardation. It is a known entity. The only thing, however, it does refute is that the notion that space is warped and that relativity is supported. Remember, it is called a theory still for a reason. And even if I were not to exist, this theory is being disproven more and more and more and more every day. And if I die tomorrow due to a heart attack, whatever be the case, I will be the first person on this little blue planet to discover how magnetism works and what actually defines the denotative definition of what a magnet is. We've had descriptions up the wazoo, and there are plenty of empirical formulas for magnetic flux density and whatnot, but there's never been a denotative description of it. And it is very, very, very simple. Seemingly complex, however. Okay? Thanks for watching. If you like this video, you can drop me a buck or two. But if you want to get a feral cell, you can go over on the feralcell.us. I have no connection to them as far as money, whatnot, so on and so forth. Thank you for watching. I'll catch you peeps